Higher Secondary Examination 2022. Mathematics, full marks 100, pass marks 33, time 3 hours, attempt all questions. The figures in the right version indicate full marks for the questions. For question numbers 1 to 4, write the letter associated with the correct answer. Question number 1. The slope of the tangent to this curve at a point 2 minus 1 is. For solution, we have x equal to 2, that gives 2 equal to t square plus thrice t minus I. Y equal to minus 1, that gives minus 1 equal to twice t square minus twice t minus 5, from which we have to eliminate t and t square, and we get t equal to 2. Dy by dx is dy by dt by dx by dt, whose derivative is this, whose derivative is also this. Put t equal to 2, we have 6 by 7. Correct answer is B. For question number 2, the value of this integral is A. For question number 3, the angle between the vector this is cos theta. Use this formula, we have this, which is minus half, which is equal to cos of twice pi by 3. Correct answer is C. For question number 4, the distance between the plane this and this is, distance between these two planes is, using modulus of c1 minus c2 divided by root over a square plus b square plus c square, we have 2. Correct answer is D. Define a symmetric matrix. A square matrix A is said to be symmetric matrix if A transpose is equal to A. Find the value of this. Tan inverse of root 3 is remains unchanged. Cos inverse of minus root 3 is pi minus cot inverse of minus root 3 is equal to pi minus cot inverse of root 3, which is tan inverse of root 3 plus cot inverse of root 3 is pi by 2, minus pi is minus pi by 2. Define an identity matrix. 1 mark. A square matrix A is said to be an identity matrix if the diagonal elements are unity and others are 0. Write the definition of determinant. For every square matrix A, there exists a number called the determinant of the square matrix A and denoted by det A or det A. If this matrix is a singular matrix, find the value of x. For singular matrix, determinant of the matrix must be 0. Expand and solve x equal to 0, 1, which are the required values of x. Question state Rolle's theorem. If a function f is defined over the closed interval ab is such that it is continuous in the closed interval ab and is derivable in the open interval ab, and f of a equal to f of b, then there exists at least one point c belongs to open interval ab such that f dash of c equal to 0. For question number 11, write the relationship between a and b so that the function f defined by this is continuous at x equal to 3. 1 mark. Given that f is continuous at x equal to 3, therefore Levin derivative at 3 equal to Ryan derivative at 3 equal to f of 3. Their function values are given. Taking their derivative, we have this, from which we have 3 times of a minus b equal to 2, which is the required relationship. Find the intervals in which this f given by f of x equal to twice x square minus thrice x is increasing. Here this, taking derivative, which is taking for common, we have this, which is always greater than 0 if x is greater than 3 by 4. Therefore, f of x is still increasing in the open interval 3 by 4, comma infinity. For question number 13, write the formula for integration by parts. 1 mark. The formula for integration by parts is integrand of f of x dx dx is f of x into integrand of dx dx minus integrand of derivative of first function into integrand of second function. Define vector product of two vectors. The vector product of two vectors, the non-zero vectors a and b, is denoted by a cross b and is defined as equal to modulus of a into modulus of b into sine theta into n cube, where theta is the angle between a vector and b vector lying between 0 to pi, including the two ends, and n cube is a unit vector perpendicular to both a vector and b vector such that a, b, and n cube form a right-handed system. Question number 15. Prove that sin inverse x plus cos inverse x equal to pi by 2 x belongs to closed interval minus 1, 1, 2 marks. Let sin inverse x equal to y implies x equal to sin y. Sin y can be written as cos of pi by 2 minus y. Implies cos inverse x equal to pi by 2 minus y. Y transform on the right left side we have this. Put y originally below y, that is cos inverse sin inverse x. We have this. For question number 16. So that 2 tan inverse of 1 by 3 plus tan inverse of 1 by 7 equal to pi by 4. Left hand side becomes this. Using twice tan inverse x formula we have this, and simplify, and lastly adding tan inverse x plus tan inverse y formula we have tan inverse of x plus y by 1 minus x into y. Evaluate tan inverse 1, which is pi by 4. Hence proof. Question number 17. Prove that if any two rows or columns of a determinant are intersects, then the sign of the determinant changes to marks. Let delta equal to this, whose value expanding in the first row we have this. Let delta 1 be the determinant obtained by intersecting the second and third row of delta. Then delta becomes this, whose expansion in the first row becomes this. Taking out minus 1 from each term we have this. The expression within the third bracket equal to delta. Thus delta 1 equal to minus delta. This shows that the intersections of any two rows or columns of a determinant changes the sign of the determinant. Number 18. Find the adjoint of the matrix A, 2 marks. Let A equal to this. We have A1, A of 1, 1, this A of 1, 2, A of 1, 3, for first row. For second row we have cofactors. For third row we have cofactors. Therefore adjoint A is, the formula is this. Put their respective values transpose. That is first column, first row, first column, second row, second column, third row, third column, which is the required adjoint. Question number 19. Write steps to solve first order linear differential equation, 2 marks. The steps are put in the form of dy with x plus py equal to q, where p and q are constants or functions of x only. Find integrating factor e to the power integral p dx. Third, the solution is y into e to the power integral p dx into equal to integrand of q into integrating factor, that is e to the power integral p dx plus c. Find the general solution of the differential equation, this 2 marks. We have this factorized right hand side and apply separation of variable. We get this integrating both sides 8 plus constant of integration, whose integral is this, whose integral is also this, which is the required general solution. For question number 21, find a unit vector perpendicular to the vector this. We have across B is this, whose expansion in the first row gives this, whose determinant is all, whose the absolute value is also this. Therefore, the required unit vector is, using this formula, put their respective values cancelling 5, 5, we have this. Question number 22. Prove that put x equal to a tan theta, whose derivative we have dx equal to a sec square theta d theta. Put their respective values, taking out and cancelling we get integral of d theta, whose integral is theta, plus c. Theta is from solve theta from here, we have tan inverse of x by a. We have this. We have proved the statement. Find the equation of the plane through the line of intersection of the plane this and this, and if which is perpendicular to the plane, this 2 marks. The equation of any plane through the intersection of to the line of intersection of the plane this and this is first plane plus lambda times of second plane equal to 0. Put in the general form. If this plane is perpendicular to this third plane, then their norman must be perpendicular. Applying the condition for perpendicularity of two normans, we have this, from which we have to solve lambda, whose value is minus 1 by 3. Put this value in the above equation. The required equation of the plane is this. Simplifying, we get x minus z plus 2 equal to 0. For question number 24, prove that the function f from R to R defined by f of x equal to twice x minus 3 is invertible. Find, or also find f inverse. For 1, 1, let xy belongs to R such that f of x equal to f of y. Then whose values are this? Solved, we get x equal to y, which is unique solution. This shows that f is 1, 1. For on 2, let y equal to f of x where x belongs to our domain and y belongs to our codomain. Then f of x twice x minus this solve x, we have this which belongs to r for any real value of y. So y belongs to r, there exists x belongs to r such that f of x equal to y which belongs to r. So f is onto. Thus f is 1, 1 and onto, and hence f is invertible. Also f inverse of x is replace this x by f inverse y, and after that we have to change is y by x. We have this, which is the inverse of the function. For question number 25, if y equal to this, find derivatives. Y equal to this, put this equal to u, this equal to b. Then differentiating both sides with respect to x, we have this. Since u equal to x to the power sine x, taking log on both sides and differentiating both sides with respect to x, we have du by dx equal to this. Similarly, b equal to this, taking log on both sides and differentiating both sides with respect to x and solve dv by dx, we get this. Put the value of du by dx and dv by dx in equation 1, we have dy by dx equal to this. This is the required value of dy by dx. For question number 26, show that the function f is continuous but not differentiable at x equal to r. Level limit at 1 equal to right limit, level limit at 1 is 0. Right limit at 1 is 0. F of 1 is 0. These three values are equal, therefore, hence f of x continues at x equal to 1 for the derivable at x equal to 1. Left-hand derivative are denoted by this, whose formula is put their respective values and taking limit we have minus 1. For right-hand derivative at 1 denoted by this, whose formula is this, put their respective values and evaluate, we have 1. Left-hand derivative at 1 does not equal to right-hand derivative at 1. This shows that f is not the derivable at x equal to 1, hence proof. For question number 26, or if y equal to this, show that this. Here y equal to this, differentiating both sides with respect to x derivatives denoted by y1, we have this, and multiply both sides by x, we have this. Again, differentiating both sides with respect to x, we get apply product rule on the left hand side, we have this, and differentiate this with respect to x, we have this. Differentiating into multiplying both sides by x, we have this, which is equal to y transfer minus y on the left hand side, this, and put their corresponding values, we have, hence proof. Question number 27. Evaluate the value of this definite integral. Let I equal to this. Using 0 to a property, we have this, evaluate, and we have this, transform minus I on the right side, we have twice I. That gives I, multiply numerator and denominator by 1 minus sin x. And for which we have cos square x divided 1 by cos square x square, sin by cos square x is sec x tan x. Integrating tan x minus sec x. Taking their values, find out, compute their value, we have twice pi. Cancelling 2, we have I equal to pi. (27) Or evaluate this. Here f of a plus r is used expand and put in the simplest form, and n is b minus a, whose value is 3 minus 1, that gives 2. Therefore, this value is equal. Use this formula, put their respective values, taking combine grouping like terms. We have this. Replace in use sum of the first and necessary numbers, sum of the squares of first and necessary numbers. Put n is by 2 and taking limit, put x equal to 0, and we have this, which is the required value. 20 ka find the area bounded by this curved line. This for point of intersection, we have this, the two lines intersect at a whose coordinates are 2, 1 and b whose coordinates are minus 1, 1 by 4. Require the area of the shaded region, which is the area of the difference of the area formed by the line and by the curve on the x-axis. Use construct this definite integral and evaluate. We have 9 by I square units. 29. Solve the differential equation given that is. Put derivative, solve derivative, which is homogeneous differential equation. So we have to put y equal to bx and dy by dx equal to b plus x db by dx in equation 1, and apply separation of variables. Integrate both sides plus log of c. Integrate whose integral is this, whose integral is using properties of logarithm. We have this. Put y by b by x, and we have this, which is the general solution. But we are given y equal to 1, x equal to 1, we have c equal to 2. Put this value in the above equation. We have this, which is the particular solution. 30. Let a equal to this, b equal to this, c equal to this. Find a vector d which is perpendicular to both a and b such that c dot d equal to 15. Across b, who expand in the first row, we have this. Let d equal to lambda times of across b, but c dot d is 15, and c whose values are this, d whose values are this. Multiply scalar, use scalar product, and solve lambda equal to this 5 by 3. Put this value in the above equation. The required vector is this. 31. Find the mean and variance of the heads in the three tosses of a affair called 4 marks. Let x number of heads in three tosses of a call, then s equal to 0, 1, 2, 3. When p x equal to 0, there is getting all t. That is 1 by I. P of x equal to 1 is 3 by I. X equal to 2 is 3 by I. X equal to 3 is 1 by I. Therefore, expectation E of x is this. Put their respective values, solve, we have 3 by 2. And for variance, use this formula, put their respective values. For Ex, put directly 3 by 2. And evaluate, we have 3 by 4, which is the required variance. 32. Using elementary transformations, find the inverse of this matrix. Let A equal to this, we have A equal to IA. Put the value of A exactly and I exactly. This A remains, and apply. First row, second row, 8 first row. We have this, and second row plus 2 times of third row, we have this, and again apply third row plus 2 times of second row, we have this. After this, row 1 obtained by row 1 plus 2 times of row 3, and the new row 1 is all row 1 minus 2 times row 2. Their product is I, therefore A inverse equal to this. So that of all the rectangles inscribed in a given fixed circle, the square has the maximum area. Let ABCD be a rectangle inscribed in a circle of radius r, as in this picture. Let x equal to AB, y equal to BC, and angle BSC equal to theta. Let a theta be the area of the rectangle, then a theta the leg into breadth x, whose value is this, whose value is also this. We have this. Therefore, whose derivative is this with respect to theta. Again, its second order derivative is this. Now a dash theta equal to 0 gives theta equal to pi by 4. Put these values in the a double dash. We have this, which is less than 0. That is a negative number. Therefore, a theta equal to pi by 4 is a point of maxima. Implies x equal to this, y equal to this. These two values are equal. This shows that thus the area of the rectangle is maximum when the rectangle is square. 33. Or a z of an enemy is flying along the curve given by y equal to x bar plus 7. A soldier placed at 7 wants to shoot down the z when it is nearest to him. Find the nearest distance 6 marks. Let pxy be the position of the z and q thrice 3, 7 be the position of the soldier. Let s be the square of the distance between p and q. Then s equal, using distance formula between p and q, we have this. Also, we have learned that y equal to x square plus 7, and put x in terms of express x in terms of s using this equation. We have this, and ds by dx gives this. Again, d square s by dx square equal to this. Now ds by dx equal to 0 gives, we have a quadratic equation in x factorized, solved x equal to 1. Second factor has no real roots. When x equal to 1, second order derivative whose value is always greater than 0. Thus s is least when x equal to 1 and y equal to I. the required nearest distance, the distance between P and Q, P whose coordinates are already found 1i. Distance between 1i and 37 we have root over 5. Question number 34. Evaluate the definite integral 6 mark. Using 0 to a property, we have this evaluate and express in the simplest form. Transfer I on the left side, we have twice I equal to this. Express sin 10x by sin x by cos x and simplify. Multiply numerator and denominator by 1 minus sin x. We have this. The denominator becomes cos square x divided in the numerator. We have sec x tan x whose integrand is sec x whose integrand is sec square x to 4 tan x for 1 x. Evaluate and simplify. We have pi by 2 times of pi minus 2. 34 or evaluate the value of this definite integral. Let x minus 5 equal to a times d by dx of x square plus x plus b. We have this equating coefficients of like terms. We have a equal to half and b equal to minus 11 by 2. So I equal to this. So I equal to put the respective values of a and b in the above expression in this. Resolve into two integrals. For this we have this. For this we have to put in this form, and using standard formula we have this. Evaluate. (35) Derive the vector equation of a plane in the normal form and hence obtain the Cartesian equation of the plane. 6 marks. Let ON be the normal from the origin to the plane and n cap be the unit vector along ON. Then ON equal to d times of n cap. Let P be any point on the plane. Then NP vector perpendicular to ON vector. So their dot must be 0. Equation 1. Let R be the position vector of the point P. Then NP equal to R vector minus d times of n vector. Therefore 1 becomes, put these values in the above. We have this. Divide is term by d. We have this and multiply using distributive property R vector dot n cap equal to d. This is the equation of the plane in vector form. For Cartesian, let P x y z be any point on the plane and L M N be the distances of the normal. And then OP equal to this and cap equal to this. Put these values in the above equation. We have this. Use scalar product of two vectors in terms of which are expressed in terms of ijk. We have this. This is the equation of the plane in Cartesian form. Question number 35. Derive the vector equation of a line passing through a given point and parallel to a given vector and hence obtain the Cartesian equation of the line. 6 marks. Let a vector be the position vector of the given point A with respect to the origin O of the rectangular coordinate system, as in this picture. Let L be the line which passes through the point A and is parallel to the given vector B. Let R vector be the position vector of an arbitrary point P on the line. Then AP is parallel to the vector B, so AP vector can be expressed equal to lambda times of B vector, while lambda is R. But AP equal to OP minus OR A. Put their respective values. We have R equal to A vector plus lambda times of B vector. Hence, the vector equation of the line is this. For Cartesian, let the coordinates of the given point A be x1, y1, z1 and the direction ratios of the line be A, B, C respectively. Consider the coordinates of any point P be this. Then R vector equal to this, I vector, A vector in terms of ijk equal to this, B vector also this. Put these values in the above equation 1 and compare equating coefficients of ijk. We have this. Solve lambda from here, solve lambda from here, solve lambda from here. These three fractions are equals. Therefore, we eliminating lambda, we have x minus x1 by a similar to others. This is the Cartesian equation of the line. Solution. Let x and y be the number of passengers traveling by executive and economy classes. Let p be the total profit and p equal to 1000 times of x plus 6000 so y. The problem is to maximize z equal to 1000 x plus 600 y subject to the constraints x should be greater than equal to 20, y should be greater than equal to 4x. X plus y should be less than equal to 200. X, y should be greater than equal to 0. By drawing the inequalities, we get the physical region DEF with vertices D equals this, B equals this, and F equals this. At D, Z value this, at E, the value of Z is this, at R, the value of Z is. Hence, the max profit is maximum when 40 tickets in executive class and 160 tickets in economic classes are sold. 37. There are three calls. One is a two-headed call having head on both faces. Another is a bias point that comes up head 75% of the time. And third is an unbiased call. One of the three calls is chosen at random and toss. It shows it. What is the probability that it was the two-headed call? 6 marks. Let S1, S2, S3 be the events of selection of a two-headed call, biased call, and unbiased call. Let A be the event of getting a head. Then P of E1, P of E2, P of E3 is being equal to 1 by 3. P of A by E1, 1, P of A by E2, 75 by 100, that is 3 by 4. P of A by E3 is half. By Bayes' theorem, the required probability is this. Applied, put their respective values and solve, we have 4 by 9. Thanks for watching.